Today we're going to relate the quantum numbers to the organization of the periodic table. So just a quick recap. We concluded that your s sublevels are made up of one orbital and maximum 2 electrons. Your p sublevels have 3 orbitals with a max of 6 electrons. D is 5 and 10, and F is 7 and 14. So I'm going to show you how these show up on the periodic table. These first two columns of the periodic table are your s sublevels, or we call them your s block. So s block. That also includes helium over here. So helium fits in over here. The only reason it got booted over here is because it behaves like a noble gas. It doesn't react with anything, and it's full. It's completely full of electrons. It couldn't hold any more. Okay, so these are your s block. Now, s blocks are supposed to have 2 electrons. So if you look, it's only 2 elements wide. So that correlates with it only having a maximum of 2. I also want to point out that every 2 electrons is an orbital. So it is 1 orbital across, right? It's 1 orbital and 2 electrons across. Okay, the next sublevel is the p group. So your p block are these columns right here. P block has 3 orbitals and can hold a maximum of 6 electrons. Oops. Okay, so that's 1 orbital, 2 orbitals, 3 orbitals, and then it is 6 elements across, right? 2, 4, 6. So that correlates with that. The next one, the D block. D block is 5 orbitals and 10 electrons. So things get a little goofy in here too, but it includes these 2 down here because it has to be 10 across. So this is the D block. This is also the D block. And again, 5 orbitals wide, so 1, 2, 3, 4, 5. And 10 electrons and 10 across. So if I count all these, it's going to be 21 to 30 is going to be 10 across. And the last one, your F block. F block is down here. And you want it to stop before these 2, before the 71 and 103. Okay, so F block was supposed to be 7 orbitals and 14 electrons. So 1, 2, 3, 4, 5, 6, 7 orbitals times 2 is going to make it 14 electrons. So we would label that as the F block. Okay, so that's the general overview. What I'm going to do now is look at the individual blocks and just give you a little bit more detail. So these are the S blocks. I moved helium from up in the right corner to over here just so that we can look at them at the same time. Okay, so each principal energy level, 1 through 7, has its own sublevels. So the sublevels in this row, these 2 are going to be the 1s orbital. These 2 are going to be the 2s orbital, 3s, 4s, easy pattern, no big deal, 7s. Okay, so nothing out of the ordinary for those guys. So this is the P block, and I crossed out helium because we moved it over here. Okay, so the P block, it doesn't have any elements in this top row, so it actually starts with 2 instead of 1. So that's orbitals 2p, 3p, 4p, 5, 6, and 7. So the only thing you need to note with that is it starts with 2 instead of 1. The D block. So here's where things get a little weird and you kind of have to remember some extra stuff. The D block starts with 3. So this is 3D, 4D, 5D, and 6d. Okay, by itself that doesn't look weird, but if we go back to the periodic table, If we go back to the periodic table, you see that the D block starts way down here on what is row 4 for the S block. So it kind of has its own rules. You just have to remember that D starts at 3. So even though this is row 4 for the S block, it's row 3 for the D block. The reason is not something that we're going to focus on in chemistry, in general chemistry, but I will tell you that it relates to these shapes. Okay, so these shapes start layering on top of each other. So originally you had just these guys, and then this is layered like on top of them. So because you end up filling in some of the spaces that you were before, that's why those numbers jump back one. But all you need to remember is that the D block starts at 3. Okay, so when you start counting the D rows, you start with 3 through 6. And last group, the F block. Again, these guys are crossed out because they were moved into the D block. I added them in right here. Okay, so the F block starts with 4. So this is 4F and 5F. Okay, so this is even a little stranger if you relate it back to where it actually is in the periodic table. So if we look at our periodic table, the F block belongs right in here, right in this gap. So if we look at our S block, 4, 5, 6, that puts it in row 6 for the S block. So it's actually 2 less than you would expect it to be, because it actually starts with 4 and 5. Okay, so you kind of just have to memorize that D block starts with 3 and F block starts with 4. However, it should be easy to memorize because they just go up by 1 each time. So starting with 1, starting with 2, starting with 3, starting with 4. Okay? So what we're going to do now is summarize everything that we've talked about in this table right here of your notes. So if our principal quantum number is 1, according to this formula, n squared, we should have 1 orbital available. So is that orbital S, P, D, or F? If I look at my periodic table in row 1, I have this and this. So that makes for 1 orbital, and they're both in the S. These are both S orbitals. So we would say that 1 orbital is in the S. So how many electrons would it hold? Well, 1 times 2 is going to be 2. And that makes sense because we only had 2 elements in that top row. Okay, if we are in principal quantum number 2 of the periodic table, according to this formula, we should have 2 squared. We should have 4 orbitals. So let's see where those are. So there's 1 orbital here, that's 1, and it's in the S group. There's 1 orbital here, 1 here, and 1 here. So that's 1, 2, 3, 4 total orbitals. Whoops, other way. 4 total orbitals, so that works. 1 of those orbitals was in the S, and 3 of them were in the P, right? 1, 2, 3. 3 of them were in the P. Okay, maximum electrons, 4 times 2, means there should be 8 electrons, which that's what we saw. There was 8 elements across that fit in row 2. So yeah, there's 8 across here, 6 here, and 2 here. Okay, moving on to row 3, quantum number 3 of the periodic table. According to this formula, we should have 9 orbitals available. So there's 1 orbital here. It's 1, 2, 3, 4. Well, shoot, we only have 4 here. We have to get to 9. So you have to remember that the D block starts with 3, starts with row 3. So you have to count these ones too. So that's 4, 5, 6, 7, 8, 9. So there's 9 total orbitals. So we had 1 orbital in the s, 3 orbitals in the p, and 5 orbitals in the d. 5, 6, 7, 8, 9. So that adds up to 9. That works out. So 9 times 2, that should have been 18 elements across. Cool. One more row to do. So if we're in principal quantum number 4, we should have 16 orbitals available. Let's find them. 1 here, 2, 3, 4. We're going to skip down to here because this is row 4 of the D block. 5, 6, 7, 8, 9. Okay, well, I only found 9. Well, the F block begins with 4, so you need to count them here. 10, 11, 12, 13, 14, 15, 16. These guys don't count. They belong up here. So that was 16 orbitals, and that matches up with what we want. So 1 orbital was in the S, there was 3 in the P, 5 in D, and there was 7 orbitals in F. So that's 5, 6, 7, 8, 9 plus 7 is 16. We're good to go with that. And 16 times 2 is 32. Okay, so if you went back and counted, you would see that there was 16 elements total that we gave this yellow orangish color. Okay, so that's all I'm going to go through in this one. I will see you next time.